Welcome to the fourth and final mini lecture on Unit 10. In this mini lecture we will be talking about galaxy collisions covered in sections 2 and 3 of chapter 25. So as we saw back in our properties of galaxies, compared to the space in between them, galaxies are relatively big. And this is different from anything else we've covered in astronomy so far. For the planets going around the sun, the vast majority of the solar system is absolutely empty space. So it's not possible for planets to collide just because they're so far apart and so small and on regular orbits. And likewise, as stars go around the galaxy, there are extraordinarily few close encounters between stars because the space between stars is vast compared to the size of the stars. Closest star to our sun is Alpha Centauri, 4 light years away, and each of the two stars are 2 light seconds in radius. So it's just empty space except for that. For galaxies, however, they're a lot larger compared to the space between them. So, for example, the Milky Way is 100,000 light years across, and the nearest large galaxy to us is the Andromeda Galaxy, which is 2 million light years away, or just 20 times the size of the Milky Way. Now that's still a lot of empty space, but relatively speaking, they're much closer. A lot less empty space than for planets or for stars. When we go to galaxy clusters, and we saw that there can be thousands of galaxies in something about the size of the distance between us and the Andromeda Galaxy, you can imagine that galaxy encounters can be relatively common in those environments. Here, when we talk about galaxy collisions, even though the galaxies themselves are big, they're still mostly empty space. And so when two galaxies collide, the chances that any two stars will collide are still exceptionally small. However, gas and dust do collide very readily. As we talk about galaxy collisions, we'll find that most of the changes come because of interactions of gas. However, the stars will still react to the pull of gravity, which results in some interesting structures being formed. When two spiral galaxies collide, you tend to form something that looks like an elliptical galaxy. As the gas collides, it very rapidly forms stars at thousands of times the rate that our galaxy is forming stars right now. And so the gas quickly gets exhausted and there's no gas left. Meanwhile, the gravitational interaction of the two spiral galaxies jumbles up the orbits of the stars. So instead of orbiting in nice flat frisbee disks, they tend to fly every which way, making something that looks very elliptical. Here's what I was just saying. During a collision, the orbits get jumbled, and so we get new galaxy shapes. And in fact, the orbits pretty much get randomized, so they'll go out in almost any direction. That naturally makes something that looks spherical or oval in shape, an elliptical galaxy. And the gas clouds in each spiral galaxy will collide and thereby trigger new star formation. So we get a lot of new stars formed in the region where things collide. Those orbits for those stars get all jumbled up, and so you end up with something like an elliptical galaxy. Here's a picture of a galaxy that is sometimes called the Atoms for Peace galaxy, because if you change the brightness and contrast, you can get something that looks like an atom with the peace sign in the middle. And this is two galaxies that collided quite some time ago, and they're almost done with the process of merging. And so here you can see, though, some of the structures that happen. We get a lot of intense star formation in the center where the two galaxies collided. And you also tend to get these two long streams of stars that are called tidal tails. This galaxy, if you sort of averaged its shape, it definitely looks more elliptical than it looks spiral, although it's still not settled here, so it'll take some more time for everything to settle down into a new elliptical galaxy. So let's look at just some pictures of colliding galaxies. I have some movies of galaxy collision simulations, including one of what will happen when the Milky Way and Andromeda galaxy collide in a few billion years, available on eCollege. So here's an elliptical galaxy that's collided with a spiral, and you see the elliptical galaxy here sort of sticking straight up and down, and the spiral, we're looking at it edge on, and so it's almost like the elliptical has impaled the spiral, and meanwhile the spiral is getting disrupted by the gravity of the elliptical galaxy, so instead of being a really flat, thin disk, you see it's warped and it's got stars forming at all sorts of different angles here. Here is a galaxy called Hoag's object, named after the astronomer who discovered it, and this one is an elliptical galaxy that's collided with a small spiral. The two galaxies collided almost head-on, and that sent a wave of star formation through the spiral, so that the inner parts of the spiral have all now dissipated and joined the elliptical, while the star formation is going outward in a ring, and so we see this ring around an elliptical galaxy. Here is a picture of a galaxy that it's a large spiral, and it has just consumed a smaller dwarf type galaxy, something like our Milky Way and the Large Magellanic Cloud. And the gravity of the dwarf galaxy is enough to warp the spiral arms, so you can see here that it looks more like a corkscrew than a spiral, and what's left of the dwarf galaxy is that long tail trailing off behind it. So the dwarf galaxy messed up the spiral galaxy completely disrupted the dwarf galaxy. So if a small galaxy collides with a large one, what tends to happen is that the large one is unfazed or slightly disturbed, but the dwarf galaxy gets completely shredded. And so computer simulations show that we should get these streams of stars. What used to be the dwarf galaxy gets pulled out in a long stream, and the stars continue to try and do the orbit that they were on before, and it will make a bit of a rosette pattern around the galaxy. Now, these were computer simulations for a long time, but in recent years people have begun to discover these exact sorts of streams around nearby galaxies. So here's a picture of a spiral. We're looking at it from the edge on, and you can see the faint stream of stars that used to be a dwarf galaxy that has been shredded over just a couple of orbits around the spiral. And the spiral looks pretty much unfazed by this. Our own Milky Way has undoubtedly swallowed similar types of galaxies in the past. It will do so again with the Large and Small Magellanic Clouds. And so one area of research are people trying to find the remains of these streams of stars in the halo of our galaxy. And there are a handful of very good candidate streams. Some people call it the spaghetti halo of our galaxy, where several dwarf galaxies that have been eaten by the Milky Way, or often called cannibalized by the Milky Way, what remains of them are streams of stars that get all wound together in something that would look like a bowl of spaghetti. So what we've learned about galaxy collisions is that galaxies can collide, and they do collide. When two large galaxies collide, two large spirals collide, you tend to make an elliptical galaxy. But if you have a spiral galaxy and a dwarf galaxy collide, the spiral galaxy basically eats the dwarf galaxy and gets a little bigger, maybe has some of these streams around it. However, the space between stars is so big that few, if any, stars will collide themselves during the galaxy collision. So the galaxies sort of collide and stick, but the stars pass on by each other as this all happens. The Hubble Space Telescope online picture gallery, called hubblesite.org, has lots of pictures of galaxies in all the stages of collisions. I'll put a link to it on eCollege so you can look at many more pictures and see what happens in the process of a galaxy collision. So this completes our mini lecture on galaxy collisions. I encourage you to watch the galaxy simulations that are up on eCollege and go ahead and complete the response to this mini lecture.